which methodology we follow and use when we design a structure. We know that there are requirements that we need to collect and define before the design. These requirements can be regulatory requirements, they could be performance requirements, and as we know, in a structure or a big infrastructure such as bridges, there are multiple stakeholders involved in the project, and therefore we need to consider all the requirements, all the conditions for the structure. These requirements can also be defined in regulations, the construction and building codes. And there might be some studies like environmental studies or traffic impact studies for the structure. And then we define the systems, the member sizes and dimensions of the structure elements, and also prepare a mathematical model based on those requirements. In the second step, we determine the self-weight and applied loads on the structure. Self-weight are dead loads, the weight of each member, and the applied loads could be, for example, live loads. They could be wind loads, snow loads, seismic loads, and those loads, which are usually environmental loads and live loads, are calculated through the software and engineering principles. We then analyze the structure to obtain the members' required capacity, and also conduct earthquake analysis if the structure is located in an earthquake zone. And then we design each member for moment, shear, axial load, stability, and torsion. We compare the strength of the members and the influences and the stresses applied to those members, and then see if the capacity basically overpass and surpasses the required strength. This process can be repeated multiple times in an iterative way. So we design a member, we calculate the weights and applied loads and see the influences of those loads, and then we optimize our sizes, dimensions of the structural elements. So this process could take time, and it could be like many times, but we ultimately define the sizes and dimensions of the structural elements, considering the economy, the safety, serviceability, and the requirements. We also check the serviceability requirements, which are usually the crack weight and the deflection. We see if those cracks and deflections are not bigger than the minimum values that are usually defined by the codes. And then if those requirements are met, then we go to design each member and detail those with the reinforcement for construction, and then we prepare the construction drawings. We also design the connections. Connections are very important to be designed safely, as they can transfer loads from members to members, and the connections are very critical and important. In the last stage of the design, we prepare the detailed drawings and the specifications. We prepare the bill of quantities, the schedules, and the construction drawings that can be used to build the structure.